Hey everybody. So today I'm going to be talking about a variation of Texas Hold'em, which is a poker variant, called three-card poker. Now you might have heard of three-card poker as a game in a casino. This isn't the game that I'm referring to. What I'm referring to is going to be a very simplified game of Texas Hold'em. So the way this game is going to work is there's going to be three cards in the deck. Only three cards and two players. The cards are going to be a king, a queen, and a jack, and we can say that king beats queen and queen beats jack. Now there's going to be two players, player A and player B, and they both have one chip, and there are two chips in the middle. So we have two chips here, and player B's got a chip and player A's got a chip. If you want, you can think of these two chips in the middle like a big blind and a small blind. So maybe both players had two chips and they both had to put one in to play the game before the cards are dealt. Doesn't really matter. And player A and player B will both be dealt one card, and there are no cards in the middle of the board. So no community cards like in normal Texas Hold'em. Just two cards. A's got a card and B's got a card. And we're going to talk about how this game can be solved. And what I mean by solved is finding the optimal strategies for player A and player B. But we're going to focus a lot more in this video on what player A ought to do here. And throughout this explanation, I'm going to be referring to a lot of topics that are quite common in regular poker and themes in poker that we can get from solving this game. So let's begin by talking about what player A should do. So there's three things player A can have in their hand: a king, a queen, and a jack. And for each card there's two actions they can do. They can either bet, which is more aggressive, or they can check, which is more passive. Now, the solution to this game is not going to be a pure strategy solution, meaning that we're not just going to say, always bet with these cards, always check with these cards. It's going to be to do with frequencies. So it's going to be something like, do this at this frequency with this card, do this at this frequency with this card. I've done a video already about paper, scissors, rock, and given an analogy for what it means to be playing a mixed strategy as opposed to a pure strategy. So, in paper, scissors, rock, there's no optimal strategy where I say, always play scissors, for example, because then the opponent will always play paper. But if I play everything in rock, paper, scissors at a 1/3 frequency, then I can't be exploited. And in a similar way here, we're going to try and find a way to make player A unexploitable to player B, which is how you would play optimally. Otherwise, they can take advantage of you. And this is going to matter more in zero-sum games. So games where, like poker, where every chip that you don't have is a chip that they have. So this idea of playing unexploitably is going to be way more important in a zero-sum game, because in a zero-sum game, if they're taking advantage of you, you are by definition getting less. But if we were playing a game that could have a cooperative element, like the Prisoner's Dilemma or something like that, then we wouldn't really use language like exploitation. Alright, so what should A do with each of these holdings? Well, we'll start with the king. King is the best hand. So if you have a king, your opponent either has a queen or a jack. In poker, this is called having the nuts. The nuts. The nuts just means the best possible hand you can have. You're guaranteed to beat your opponent or tie with your opponent. Now in this game, it means you definitely beat your opponent because there's only one king on the deck. So it seems reasonable that you would want to bet with this king at an 100% frequency. And this is actually correct, which means checking at 0% frequency. This is correct because if you have the nuts, you've got the best possible hand and you're player A. You know that you've won these two chips in the middle. You're guaranteed to. There's no point checking, because if you check, they might just check back, which means you win the absolute minimum. You are always going to win these two. So if you just walk away with these two and nothing else, you haven't really done anything good for yourself. Your goal is to get player B to put in their chip. So you should be betting your chip, so that then they will at least have a chance of calling you. So as a king, you should be betting with 100% frequency. Now, if you have a queen, This is a lot more interesting because if you have a queen, this is one of those scenarios where you won't know if your opponent is beating you or not. So if player A has queen, that means that their opponent has either a king or a jack. So let's just talk about what would happen if you bet with your queen. So let's say you've got a queen and you put your chip in the middle. What is your opponent doing? So if your opponent has a king here, they're going to snap call you. They're going to instantly call because they had the nuts, right? So you bet the queen, they have to call you with the king and you lose. You put a chip in that you shouldn't have put in. Now, if you bet with the queen and they have a jack, they're going to instantly fold because the jack is what's called the anti-nuts. And the anti-nuts means the worst possible hand you can have, or the reverse nuts, it doesn't really matter. The idea is that there's no utility in calling with the jack if someone bets into you. Just fold the jack, it's the worst hand, you cannot win. So by betting with the queen, you're getting everything better than you to call and everything worse than you to fold. So if your better's getting everything better to call and everything worse to fold, the question is of what use is the bet? What are we doing with the bet? If they have a jack, you're going to win these two chips anyway. And if they have a king, you're going to lose these two chips anyway. So all you're doing by putting your chip in is making it so that if they have a king, they win an extra chip. That's all you're doing. There's no point betting with the queen. And in fact, the queen bet frequency is therefore going to be 0%. In poker, the queen has something that we call showdown value or showdown equity. The idea being that the hand isn't bad enough that you should just try bluffing with it. It's just good enough that you might as well try and check and get to the end because the queen might be good enough at showdown, which is when the cards come face over. This is why in poker, typically when you're getting really, really big, it means that you either have something really good or something really bad. This is called a polarized range. So the range of cards that you can have are more extreme. If you're playing poker and there's a full house available and someone's betting really, really big on the river, they probably either have the full house or they have absolutely nothing. There's no way you're doing that with just a pair because a pair has showdown value, like the queen. You would never bet with just a pair because all the full houses are going to call and all the bluffs are going to fold. So there's no point betting in that situation. Now the jack is a lot more interesting. I'm actually going to change these numbers from percentages to just numbers 1 and 0, and you'll see why in a second. So the king should bet at a frequency of 1 and check a frequency of 0. Queen should bet at a frequency of 0, check at a frequency of 1. Now we're going to figure out what the jack betting frequency should be. Let's start by looking at why it can't just be 0. It feels like maybe it should be 0 because the jack is the worst hand, so why would you ever put a chip in with the worst hand? The reason is because if you put a chip in with the worst hand, you might get them to fold a queen. Now they're never folding a king. Let's get that out of the way first. If you bet with the jack and they have a king and they're going to call you immediately, then you're going to lose. That's kind of like, tough luck. But if you have a jack and they have a queen, you might have convinced them that you have the king. If you can get a hand better than yours to fold, then your bet absolutely does have utility. Another problem is if you don't bet the jack at all, that means that the only time you're ever betting is with a king, which means that when you bet, there's a 100% chance that you have a king. So your opponent can just fold these hands for free when you bet. The only reason you're betting with a king here, really, is because you want to get called by a queen. You're not getting called by a jack, obviously, because the jack is always going to fold if you bet. But if you have a king, you want them to call you sometimes with the queen. And if they're going to call you sometimes with the queen, that means that from their point of view, you have to be bluffing at some frequency with your jack. So let's call that frequency P, and we're going to solve for P, and it stands that the check frequency will be then 1 minus P, because these two have to sum to 100. Cool. All right, well, let's talk about that. I'm going to rub some of this out. All right. So part of our goal, well, let's first think about player 2's perspective, or player B's perspective, sorry. So this is our player A table. So let's think about player B. I'm going to draw my people back here again. 2 in the middle, and they both have 2. And this is player A, and this is player B. Now from player B's point of view, what are the odds that you have a king when you bet? So we're going to say the probability of a king given a bet. Well, it's going to be 1 over 1 plus p. And that's because the total ways that you can, the total number of situations where you bet is going to be 100% plus whatever this percentage is. And at one of those times, or at 100% frequency of those times, you had the king. So let's say p was 50. If you had a 50% chance of bluffing with the jack and a 100% chance of betting with the king, that means that when you bet, you're going to have a 2/3 chance of holding the king. This is where that comes from. So from player 2's perspective, the probability that you have a king given that you've bet is going to be 1 over 1 plus p. And the opposite is also true. The probability that they are going to be bluffing when they bet is going to be p over 1 plus p. And hopefully you can see that these two numbers sum to 1 because they obviously have to. So now they can calculate what player 2 is going to want to do here. Now the goal of game theory, to be game theory optimal, is to have a strategy that's unexploitable. You don't want to have any strategy here that's going to make player A, or it's going to make player B favor calling you more with their queen or calling you less with their queen, because otherwise they're going to get an edge over you. Right, so there's a sense in which if you bluff with the jack too much, they're going to call more, and they're going to win more of those calls. But if you don't bluff with the jack enough, they're going to fold more, and you're never going to get value from your kings. So we're going to find the optimal way to make player 2 indifferent between calling and folding with their queen. So let's say player 2 is a queen. Player 2 has queen. Now let's say that the player 2 call value. So you bet and they call. What value do they get from this? Well, if they call and they're wrong, they lose 1 chip, so they get -1 value. So they get -1 times the odds that they're wrong. Now the odds that they're wrong are going to be the same thing as the odds that you had a king when you bet. So it's going to be -1 times 1 over 1 plus p. Now if they're right, how much value do they get? Well, if they're right, they're going to kind of win 3 chips, because it's the 2 in the middle plus the opponent's chip will also be 1. So if they're wrong, they just lose 1 chip of value, but if they're right, they win 3 chips of value. So it's going to be 3 times, and what are the odds that you're bluffing with the jack? It's going to be p over 1 plus p. Cool. This is the probability. This is the value that player 2 gets from calling. Now, what's the value that player 2 gets from folding? 0. Always 0. They haven't lost a chip, they haven't won a chip, they get 0 value. Now, in order to make player 2 indifferent between these two decisions, folding and calling, these two values have to be equal to each other. So let's set them to be equal to each other and see what we get. So it's going to be 0 equals all this stuff. So I'm just going to add this to both sides first. So I'm going to end up with 1 over 1 plus p equals 3 times p over 1 plus p. So what can I do here? This is going to be the same thing as saying 1 over 1 plus p equals 3p over 1 plus p. And now I'm going to times both sides by 1 over 1 plus p. We're going to end up with 1 equals 3p. And therefore p equals 1/3. And that is the answer. P equals 1/3. So when you're player A you should be bluffing with this jack at an exactly 1/3 frequency. Bluff a third of the time, which means that you should be checking exactly 2/3 of the time. Alright, we're nearly done. We have one more interesting scenario to look at. I'll rub all this out. And this is what happens when your opponent is calling you, is deciding what they should do with their queen. So let's say you're now player 2 and your opponent has bet, and your decision is now, do I want to call with the queen or do I not want to call with the queen? Now again, they want to make you indifferent between whether you bet or you didn't bet. And I think actually I won't do the math here because the math is basically the exact same. But the ultimate finding is that player 2 should be calling you, or player B I should say, calls with the queen. At a, if I fully solve it, it should come out as 2/3 frequency. And that's basically, yeah, that's all the really interesting situations. Again, it's a very simplified version because in 1/3 of the time you're going to know for a fact you have the best hand, and in 1/3 of the time you're going to know for a fact you have the worst hand. So the queen is the only really interesting thing, and that's why the jacks have to bluff sometimes. So the solution is, if you're player A, you should always bet the king, never bet the queen, and bet the jack at a 1/3 frequency. And if you're player 2, you should always call the bet with the king, or always fold to the bet with the jack. And if you have a queen and they bet, you should be calling at a 2/3 frequency. And this is how both players can stay completely unexploitable. If any player does any strategy besides this, then in the long run, their opponent is going to be able to get an edge over them. And that's what it means to play Game Theory Optimal, GTO. Now, some people love to add more cards to the scenario. Like, let's say I added a 10. And as soon as I add a 4th card, the math just gets so much more complicated. Like, and I mean like way more complicated, to the point where I couldn't do a video about it. It would have to be software I write. This is the most simple version of the game that we can actually do the math. You add any more cards, or God forbid any more players, and these tables are going to become 4-dimensional, and there's just going to be too many numbers, too many calculations, and we can't do it. This is what computers are really good at. So poker is actually a solved game, and there is a Game Theory Optimal way of playing poker. But the nice thing is that no human can memorize it, because there's just too many combinations of things. There's too many unique spots you can be in. Whereas in this game, there's only like 9 unique spots you can be in. You can be A or B. You can have 1 of 3 cards, and either they checked or they bet. Cool, and I think that's all for the video. So this is a very, very simplified version of poker, and why you need to bluff sometimes with the worst of it, but never with the middle card. Yeah, cheers for that. Thanks for watching, guys.